crashing the party a little bit here, because I'm going to talk about late life and continued production. And I'm also going to give an example at the end, a case study, which you've heard some of already from Nigel's chat earlier in the previous session. And this will be a different view on the same case study. So, what is involved in this? Well, late life extension and operating efficiency and production efficiency. They're all pretty fundamental. I've heard a lot about each of them, but they're all ultimately totally related. But how we address each of them and maximise the best from each is something that really needs a bit of thought. So, a great example of one of the philosophers of our time here is one of our ageing assets. Nigel will recognise this. That was a good idea using Victor, by the way. So Victor is like an ageing asset. And the thing with Victor, as he's aging, he has certain challenges himself. For example, Hargreaves arteries, perhaps worst case scenario, heart attack, as you see, kidney stones, perhaps, windy pops, perhaps. Less power as you age as well. The strength isn't there anymore. Arthritis, and here we have dementia as well. And for those learned friends in the audience will recognise, Victor kind of spelled in dementia. So what does this all lead up to? This provides increased sick days. You can see the analogy here between an aging facility and Victor here. For likes of scaling and corrosion, heart attack, loss of power, guaranteed to get OIM, perhaps a heart attack. Kidney stones, blocked drains, windy pops, loss of containment. I'm not sure which is worse. I wouldn't really want to be there for either. Less power, gas deficient, a big problem with the ageing assets and access to gas. Arthritis, fabric maintenance, again, something that has to be addressed. And finally, fundamental to everything, like the brain, is the reservoir and what's left in the reservoir. So once that depletes as well, the facility isn't operating so efficiently, with so much value. So that all also adds up to unplanned shutdowns. And unplanned shutdowns, as we know from oil and gas UK's assessment, was about 65% of time available, so that's 35% unavailable, which is a huge amount of revenue unavailable. So what we really need to manage all this sort of stuff is a recovery programme. So it says we didn't get the doctor you wanted there. So the recovery programme, now, this is what the case I want to make here is for people, there's no fixed type of challenge or problems with them. They're all very different, and it's the same with the facility. Every recovery programme is different. So you really have to understand what the problems are and what's the best, most cost-effective fix for the duration that facility is good for. And when you put the fix in, you may extend the duration. So they kind of go hand in hand, these issues. So that's it. There's no one silver bullet, or there's no one size fits all. Within the UK continental shelf, and fundamentally pretty much everywhere, there's four challenges here. First one is production efficiency. As we know, it's only about 65% available. And this chart here is from the average unavailability. And as you can see, so it's split into well work and reservoir. That's that section there. The rest is planned, unplanned shutdowns. Is from here all the way down to here. This is the planned. This is the TAR, the TARs, and the turnarounds. And this is the planned shutdowns. This is the unplanned shutdowns. Almost 50% of unavailability. Then the last bit here is export routes, accessibility of the export routes. So you can see there's a big issue here in unavailability due to unplanned shutdowns. So that's about 20% of the whole 100% availability. So that really needs to be addressed. That's 20% additional production, just fixing that. What I've done here is trying to summarise it into three types of issues. One is reservoir and wells, another is equipment process, and finally is there's the last bit you don't see here at the bottom is the export route. So that's the first thing. Second thing is the challenge we have is in operating efficiency. That's gone up about 12% every year in the last 5 years. And we heard yesterday, half of that is due to the cost of things, and then the rest of it is mostly due to inefficiencies. So both can be addressed, and both are getting addressed very well by operators at the moment. Fundamentally, inspection, maintenance, collaboration, logistics, POB, planning, procedures, leadership, really key issue, leadership, getting that right, range time, data management. So there's a whole bunch of stuff to deal with there. So again, where do you put your effort and your energy? And this is a summary of last year's lift costs, depending upon where you were in the field. So if you're in Northern North Sea, lift cost was roughly $40 a barrel, and the Southern North Sea is about 19. But on average, the UK lift cost is $27.6 a barrel, which is not great news really when you think you go to some other parts of the world and you're single figures. I mean, where are the operators going to put their money for the developments? So we have to work on that as well. So, and then finally, the third real major challenge is I'll go into the fourth, which is a summary of these. The third major challenge is aging assets, and integrity goes down, the operating cost goes up, the base production goes down, and the field life also goes down. And this is not just about what's left in the ground, this is about what's the price of oil, because the reduced price of oil, the reduced field life as well. So there's a lot of issues associated with aging facilities, and hence, there's a lot of talk about decommissioning. So this graph summarizes all this. So with time, the production, you see the blue goes down. With time, the operating cost going up about 10% a year, and you get to a stage where it actually becomes uneconomic to operate the facility. And we know 20 to 30% of facilities out in the North Sea are there just now. And with the price of oil going, that number increases to 30 to 40%. Okay. Now, what this is saying, maybe after that you can go life extension, or you can just go for decommissioning. And what we have found in the past, we can increase the production and reduce the operating cost, and therefore take this figure out for another 5, 10, 15 years. So what that does, it gives you an area in the centre here, which is profit. And that's not just profit, it's not just cash flow, but also it's deferring the cost of decommissioning, 200 million plus deferred. So that money can go elsewhere within the company to find wells elsewhere. And then what we've noticed, we've done some analysis of every facility we've looked at, actually we find we can do something with, but we're saying 90% of facilities can benefit from this sort of assessment. So we need an approach to do this, and this I would say perhaps is the blueprint for MER, getting the approach right, because certainly there's no one fix, but if we get the approach right, the first part of the approach is to simplify. So we'll simplify, split this up into late life extension and production efficiency, and then the last one is late life extension and operating efficiency. Just have to keep it simple. For the production efficiency, split into 5 areas. The first is the wells, and then look at the well profile and look at where we can increase production from the wells, drill for attic oil, put in ESPs, improve the water injection system. It's getting the wells, and it's like was saying, if you've got a derrick available to you, then it's much easier to get local wells infill drilling. So that's the first part. The second bit is power. Power is fundamental to everything, and the unavailability, a huge amount of it is due to power. It gets attributed to many other things, but power is the first thing. So it's reliable power generators and reliable source of energy for them. Third one is the process. The process for all these old kit was designed 35, some cases 45, designed 45 years ago. The production going through that is nothing like it was designed for. So there's great opportunities to make it run more efficiently, remove whole swathes of equipment, so you reduce your maintenance and inspection budget. And also you increase the availability because less things go wrong. You also make it safer because less things leak. So simplify the process. Then the controls. The controls and the ESD and the F&G, again, they're old kits, so they fall over more frequently. Plus the control, if you're not running smooth lines, you can lose and take a trip. So having smarter control systems and less likely shutdown as well from sort of the older style shutdown systems. And finally, integrity, and that integrity actually ties into the bit below. Equipment failures, aging assets. There's really good KP 1 through to 4 processes HSE have been initiating. So that part of it as well. So that's simplifying, just breaking it down to these 5 key areas then allows you to get operating efficiency, production efficiency, and operating efficiency, really it's down to these 3 packages, all about people, processes and systems. And if you get the people right, you get the right PB, the right leadership, and just the right culture, you can do a huge amount. Processes, these are all processes that you just manage, you run and organise more efficiently. And systems, data management, there's so much data generated, but how much of it is used effectively. And also the likes of inspection and maintenance. Is that done? What's the ratio between breakdown and repair and preventative maintenance? And also, is there any risk? How much risk is it assessed against? What's the risk against? Is it against what really is the loss and failure, and how much? What's the downtime? So there's a bit more work can be done here as well. But that's simplifying the 2 key areas for efficiency savings. And finally, well, this is the second part of the approach, and it's getting the method right. So if you're going to address a facility, you have to then sort of look at it from a distance and try and deliver these 3 things at the end. Increase production, increase operating efficiency, and increase the production. So it's production efficiency, operating efficiency, and enhance the actual production from the wells. So all these 3 are good. One alone is pretty good, but if you can get all 3 of them, you've really cracked it. And that's what the suggestion here is. It's like the sum of the parts is greater than the whole. And they're quite symbiotic, so you can find one thing that actually delivers more than one result. So the key, this is the approach. Gather the data, gather the knowledge, and come out with the ideas. It is that simple, and once you get the data, you get this is where a lot of the real data is, and the knowledge. So you sit and you chat with operators, the subsurface guys, and you find out where the real issues and opportunities are, and then you generate the peak improvements. These are good improvements, but they have to then be costed against the metrics of what the key metrics for the operator. Usually a cost in the maximum production, minimum downtime when you implement it. And then you optimize the solutions and come up with recommendations. There's nothing really rocket science here. But that's the praise section. Then into the select, is then take these ideas and review it with the major players, which are the sponsors, stakeholders, technical authorities and operators, and then hone them down. Some ideas will get discarded and others will go forward to select. And from that, just develop the basis for the design, the P&IDs, the heat materials, sometimes at a level of data sheets, but certainly enough to cost it, and develop statements of requirements. And from that, quite often you can find low-hanging fruit that goes straight into implementation, and that's a big, quick saving. Or it's something that goes a bit more longer term, like the Thistle. You go into proper detailed design, procurement, construction, startup. And they're in the construction phase right now, particularly shut down a couple of days ago. So that's the approach. There's nothing too radical about it, but it's got to be done sequentially. And it's something we've developed. We've done this 4 times. We've pretty much honed it now. And this is the last part of it, which is really just putting visibility into what you're doing. So I guess the way to describe it here is this is the production efficiency, and that's at the time. This is the timeline. And this is the operational efficiency and OPEX, and operating costs coming down at the time, production going up at the time. And this is the schedule of activities. So the first piece is the appraise, the select work, and then you go to the early wins, and then just take that work and implement it across the life cycle of the project in 1, 2, sometimes 3 years. But the beauty of this thing is it actually builds up a visibility. So this can be the website, it can be offshore, but it brings a bit of visibility into the activities that are being undertaken. And so it brings in enthusiasm. Everyone's built into the idea of improving the production efficiency and reducing OPEX. It's like, a good example is like, say the church wanted a new roof, and they would go around this the area and say, right, okay, we've got this thermometer of we want to get £100,000 for the roof, and everyone chips in, and every week you see it improve. You know, it just brings in a certain ownership associated with it. So that's the third part of the approach. And what I was going to do is then quickly go through what we did in the Thistle. So the Thistle late life extension, what I was talking about there is this idea. Thistle was late life extension of production efficiency. That's what it was. It was split into 5 areas. These 5 areas were done by Enquest, and we did the concept for the process select and the control and ESD upgrade, but particularly the process select, process simplification. So that the benefit, actually that should be 15 MBD. It went up to 18 MBD, but the production was just restricted due to export capacity. So it's a fantastic story when you think this platform was COP 2015. And yeah, it's what we use the same approach as we described there. It's just appraise, select, and just went sequentially through it and got a huge amount of input from the operators and the reservoir group, and that helped us develop the design. And this design it's radical, it's swathing cuts on the facility. And I'm going to give you a little bit of idea about what we did. I'm not saying this is what you do for every facility, because sometimes you just need a small modification, and you can make big wins. So it's about many things. It's about ultimately it's about what's in the reservoir and what you get out of it, and that then determines the budget. So process simplification. Now, I really should apologise for this, but I'm a process engineer, so I had to put something like this up here. So what we did in the Thistle at high level is, so starting from here, we took the manifolds and reduced all the manifolds to low pressure, so we maximised production out of it. We took the 8 separators that we were operating, we actually increased production, but we reduced the 8 separators to 3 by just being smart with internals. We took the flare system. There was 2 big flares that were going all around the facility. We chopped it into 1 flare, an MP flare, and minimised its routing, so much more simple, much less leak sources, etc. The oil export was left because that had recently been upgraded. The produced water system increased the capacity because we increased the water injection availability, so thereby we got more water back, but that didn't matter because the percentage of oil was the same, so it meant more oil. But we had to handle extra water capacity, so we increased the capacity of the existing water injection, of the water production system. For the drains. The drains was the drains was the one that the platform didn't like too much, but the rest of the onshore guys did, and that's we took all the drains topsides. So all the pipework, everything was from under deck, which was a problem if it leaked. It meant you were down for a while, you could get the skip. And under deck scaffolding, dance floor, really expensive job, a lot of downtime. All the drains topsides. Flat drains, which was a challenge, but we just used more smart materials. And it also made inspection was much less, and maintenance costs were almost nothing. And if you failed, you saw it instantly. Things like the water injection, we increased the availability of the water injection, which meant we kept the voidage up. The voidage fraction was always filled in the reservoirs, so the production was up much more. And also the firewater system, things like this, the firewater system, everywhere you go, eventually the firewater systems are not well designed because they're designed for risks that were 35 years ago. So we have the design demand case, which allowed us to minimise the amount of pumps we needed available, to reduce the maintenance associated with that as well. Yeah, it's basically we looked at most systems, and some were pretty good, and we didn't spend money unwanted. So that's a quick overview of that. Kind of in summary here, we think most facilities can benefit from a review. Typically 10 to 20% additional production, that comes from additional uptime due to availability. It also comes from interfacing with the reservoir subsurface to see where we can debottleneck and maximise production. In doing so, the OPEX will go down because you've got more oil. But also simplify it. If you simplify and remove, like for the Thistle, we took out 5 modules, no, 4.5 modules. 4.5 modules that we're no longer producing, didn't need to walk into, didn't need to look at. Massive saving in operating costs. We rate at least 90% of facilities can benefit from this sort of thing. And just little numbers, some numbers here. If you had a 10% improvement from something that was doing 10,000 barrels a day, then that would be 60k a day additional. I mean, that pays for the study. And then day one you pay for the study. Say the equipment costs 5 million, so you've paid for it in 100 days, and everything then is additional production and deferment of abandonment. So you get that 200 million you don't have to spend. Anyway, I think that's pretty much it. So thank you very much.
Questions? I've got a flip question, which I'll chuck in. Well, you say 90%. Have you been on an installation and start the process and have a look at it? I could walk away. Have you actually seen cases that you know can't be saved through your process?
Yeah. We only get onto the facility once we've got a case in place. but I have to say, I've been on them after having a case in place thinking, this is not an easy one.
Yeah, Victor Alex. There's a comment you made at the beginning. I actually see that this and the decommissioning does actually go hand in hand. The last thing you're saying is that you're taking out modules. So I'm asking a question. I guess when you're taking these modules out, they are isolated in a state that they are effectively being decommissioned, and the next thing that's going to happen to them is that they're lifted off a structure. So.
Yeah, absolutely. Not physically touching them, except for all the communications and connections that are outside the module. So there's the module, disconnect outside the module, all the mechanical and electrical connections. So thereby, there's nothing, there's no carbons and no electrics inside the walls of the module. So no risk.
And in terms of how much of the process was actually impacted, I mean, percentage-wise, or tonnage-wise, how much are you taking out, or how much man-hours of yearly maintenance are you taking out?
Yeah, and we were asked to comment on the amount of equipment. So it's over 50% of the equipment is now just not used anymore. The whole gas system was taken out. Half the flare, a lot of the drains. Yeah, firewater, huge swathes of firewater pipework that was leaking regularly was taken out as well. Yeah.
Okay, last speaker, Tim Walsh, Chief Operating Officer, Insurance Operations.